The OmniScan MX2 B scan is available from the Display Layout menu for any layout that contains a B, or in Omni PC by right-clicking on the title bar and selecting from the same list. Prior to selecting the B scan, in a weld inspection, the primary display is the A, S, and C scan, and we would typically do length sizing on the C scan on the horizontal axis using the S, M, and SR readings, and we would do depth and height sizing on the sector scan and A scan using the ultrasound rulers. It is only on the B scan that we have the ability to do length and depth sizing at the same time on the same display. The C-scan, uncorrected amplitude-based C-scan, is the result of the gate. Every A-scan in the sector scan, for every millimeter of travel by the scanner or probe, generates the pixel for the C-scan. The advantage of the B-scan is that I can see both the depth, height, and length of a flaw in one 2D display. The disadvantage is I can only project that for one focal law at a time. So in our B scan, under the display overlay indicators, we will include the legs of the first skip that we see here at B0, and then from the first skip to the second skip on the A scan and B scan here. So on the flaw we're looking at now, we can see an ID connected crack on the S scan and C scan. So if we first take a look at where the crack corner trap on the inside of the pipe, or at B0, we can see the projection and length sizing, and we will add our cursors to the B scan. We'll move the UT cursors out of the way. Hold down the control key and double click, and we will get a red reference cursor. And as you can see, we're defining where the flaw starts. So as I move the scan axis data cursor, I can see the flaw. I can still see it in the S scan and in the B scan and in the C scan, and we've identified the edge of this with a red reference cursor. Then I'll take the data cursor and move it through the flaw. Here again we see the corner trap and multiple facets from the tip diffraction. Here's our deepest tip. Okay, we've still got the flaw. We've still got it. This is the ID corner trap. And we will identify the right side of the flaw where it ends. And depending on the type of probe, the frequency of the probe, a rapid drop or some type dB drop technique is typically used. So we will hold down our Alt key in Omni PC and double click to give us the green cursor, and we will identify the right side. So our length sizing at the area where the crack breaks the surface has been identified. Now we can do our depth and height sizing. And again, this projection that we see is at B0 where the crack is breaking the ID surface, and we can see a little bit of projection here of the different facets. So I'm going to move the data cursor back to the middle of the flaw, or it looks like where the worst case scenario is. And we will zoom in on the sector scan. And we can see here the corner trap from the ID and the projection or the shear wave tip diffracted signal representing the deepest part of the crack. So we will enable cursor mode and bring a cursor down right on the deepest part of the crack tip. And again, we can take the data cursor and move through the S scan, ensuring no deeper tip comes up. And we want to identify the very center of the energy. For the bottom of the crack, we've already determined that it breaks the surface, so I can place a cursor on the B scan at exactly the component ID. And as I move the angle cursor down through the crack and zoom in on the B scan, we can see the various facets of the crack projected on the scan axis across the probe movement and the depth and height. So to record the flaw, we will rezoom, select the center of the energy, where we have the crack tip, the crack base, and the length sizing defined as well.